Lesson 8.7 Discriminant and Complex Numbers. Now we're going to take a look at the quadratic formula and look at one certain piece of it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to focus on the discriminant, which is what is inside the root. The b squared minus 4ac is called the discriminant, and it is the piece that's inside the root. And you can tell a lot about what your solutions will be like if you know what number is inside the root. And the table below gives us a good idea, or summarizes and puts it together, about what the discriminant actually tells us. Here we have three different equations, the graphs of those three equations, and then tells you what it looks like. Now if we look at this closely, we know that when we have a graph like this, these are called the zeros, the roots, the solutions. 2 and 4 are the solutions. There's two of them. And 2 and 4 are real numbers, so you have two real solutions. And we have two real solutions if the discriminant is positive. In other words, here they calculate out with that equation what b squared minus 4ac was, and you got a 4. That's a positive number. All we care about is if it's positive. If it's positive, we have two real solutions, and that's what the graph showed us. If our discriminant happened to be 0, it means we only have one real solution, and it would look like this graph, where it only intersects our x-axis at one point. That's how we get one solution, one x-intercept. Now if we have a graph that does not cross the x-axis, we would normally say 0 solutions. But actually it's 0. We have no real solution. In the big scheme of things, if you get into detail, which is what we're doing right now, we do not have any real solutions, but we do have two imaginary solutions. And how does that come about? Well, it's because there's a negative inside that square root. And we cannot take the square root of a negative number and get real solutions. So therefore we have a problem. We have a square root of a negative number, and which means no real solutions. The graph shows you that it does not intersect the x-axis, so it verifies that there are no real solutions. But we do have two imaginary solutions, and we're going to talk about what that looks like when there's a negative inside a root. But again, a very good table to show you what they all look like. Two solutions, two intersection points on the x-axis, two real solutions. The discriminant was a positive. One real solution, one intersection point, the discriminant was 0. No real solutions, which is actually two imaginary solutions, and that's when you have a negative inside the square root, or in other words, the discriminant is negative. Now let's take a look at, we're going to come back to this one in a moment. Let's go instead to something a little more pertinent. Here, example 2, what is the discriminant and what type, how many and what type of solutions are there? So again, we're going to use the discriminant here. In other words, b squared minus 4 times a times c. If this is in standard form, in which it is, a is equal to 4, b is equal to negative 28, and c is equal to 49. Alright, that means that the discriminant will be negative 28 quantity squared minus 4 times a times c, which is 49. Negative 28 squared is 784. Negative 4 times 4 times 49 is negative 784. And we get 0. So what does it mean to get a discriminant of 0? Well, by our table, it means that there is only one intersection point. So we have one real solution. So describe the number, that's 1, type of solution, that's real. So one real solution, and that's what our table says. In this one, we have to make sure it's in proper standard form. So we get x squared minus x plus 1 equals 0. In this case, a is 1, b is negative 1, and c is 1. So b squared minus 4 times a times c, negative 1 squared is 1, minus a negative 4 times 1 is negative 4. We get a negative 3. What does that tell us? Well, when the discriminant is less than 0 or negative, we have no real solutions, but we're going to describe it as two non-real, or actually the word we're going to use is imaginary. Two imaginary solutions. Now let's check our table again. Two imaginary solutions when you have a negative discriminant. Okay, now don't worry about the values themselves. Worry more about the fact that it was positive, it was 0, and then it was negative. That has more weight than what the number actually was. Okay, so let's look at a graph. Again, we have a graph that does not touch the x-axis, therefore it has no real solutions. In which case we would say that it would have two imaginary solutions. Okay, what does that mean? That means the discriminant must have been a negative number. Here we have a quadratic equation, a parabola that intersects the axis in two places. That means two real solutions, which means the discriminant must have been a positive number and not 0. If it was 0, it would only have one intersection point. So positive number. Alright, so let's go back now to a previous question. What do you do if you have a negative inside a square root? Well, through lots of deliberation, the conclusion is that we would handle it this way. We would say we would need two key pieces of information. The square root of negative 1 is I. And if you take I and square it, you get negative 1. Those are the properties that we need to go further. So if I have the square root of a negative 81, I'm going to rewrite that as the square root of a negative 1 times 81, which means it's the same as the square root of negative 1 times the square root of 81. Now I need to know this because as we learn this process and begin to understand what I is, the square root of negative 1 is I. The square root of 81 excuse me, is 9. So the official answer to this is 9I. Okay, let's jump to this one. What is I squared equal to? Well, I squared is equal to a negative 1, which means this is the same as 30 times a negative 1. In other words, negative 30. The square root of a negative 56. Well, if you follow what we're doing here, if we have a negative inside the root, we can take that negative out and it becomes an I. And that's where the negative goes. It becomes an I. Just like negative square root of negative 81, we had an I in the answer because the square root of a negative 1 is I. So the shortcut is just to say, if there's a negative in there, take an I out and you have now a root of a positive number. 56, factors of 56, 8 and 7 I believe. 8 you cannot root either one. So 56 divided by 4 is 14. So this is the same as 4 times 14. I can root 4. Root of 4 is 2. and I still have that 14 inside, so this would be considered the most simplified version of that answer. We cannot leave a negative inside the root. We must go further. Now this is actually a pretty big thing in terms of brand new and quite interesting, so don't expect to get this off the first bat, but it is something you need to practice. Alright, let's go down to our last question here. Solve using the quadratic formula. We're going to add 6x to both sides. I get x squared plus 6x plus 13 equals 0. A equals 1, B equals 6, and C equals 13. So x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2a. So negative 6 plus or minus the square root of 36 and a negative 4 times 1 times 13 is negative 52 all over 2. So negative 6 plus or minus 36 minus 52 is negative 16. Now before I go any further, let's state one thing. I have a negative discriminant. The number inside the square root is your discriminant. In this case, it's negative 16, which means we're going to have two imaginary solutions. Okay, which means if we were to graph it, there would be no intersection points. So what now? Well, we just talked about simplifying that. So let's take a look at this. We have negative 6 plus or minus. Well, a negative inside the root is an I, and the square root of 16 is 4. So the square root of negative 16 is the same as 4i. The negative came out and became an I. The square root of 16 is 4, so you have 4i. Now, what does that mean? Well, you can actually leave it like this as we go through this, but we'd probably want to simplify it further. We have negative 6 plus 4i over 2 and negative 6 minus 4i over 2. Now notice that all three of these pieces, negative 6, 4i, and 2, are all even numbers. So I could actually divide that all by 2, and that would give me negative 3 plus 2i. So I basically took a 2 out of everything. I can do that down here also. That equals negative 3 minus 2i. And these are called complex numbers because we have an imaginary part and a real part. So together that gives you a complex number. Alright, this ends lesson 8-7.